Hello, everybody. This is recording 6 for data structures. Now, yesterday I sent you a homework. I sent you a homework, and I sent you notes 3, which showed what the homework was about. And what I'm going to try to do today is go over that material. Now, I'm having a little trouble right now. There it is. So the notes I sent you were notes about making a real abstract data structure. The real abstract data structure we were looking at was the unsorted list. Now, to do that, we had a list of things that we had to provide. And I'll pull out what I gave you before. The user had to provide the following. He had to provide the maximum number of items, the maximum size of the list. Now that's only if he's using arrays. If you were doing it by linked list or vectors, I don't think you'd need that. Item type, which is basically the item we're going to use and how to compare two elements in the item. And the relation type is an enumerated type. Now, I gave you an example of an enumerated type, seasons. The funny thing about an enumerated type is they're really integers. Spring is 0, summer is 1, autumn is 2, and winter is 3. But we can use the names, and we can even use them in arithmetic. For example, in my sample here, if S is autumn and I add 1 to it, I get winter. So the enumerated type is a useful way to define something. The advantage it gives us is that the system enforces the rule that we don't use anything but those 4 values. So we can't accidentally use something else. That's the advantage of an enumerated type. Now, the ADT itself has a set of operations, which I'm going to put over here. And these are the typical operations. Creating the list, determining if it's full, getting an item from the list, putting an item in the list, deleting an item from the list, and pushing back so that the current pointer is pointing to the first item of the list. There's always a requirement that we have a pointer that tells us what the last thing we accessed was. If we haven't accessed anything, then it's before the list, and the next item would be the first element of the list. If we've accessed something, then it's the item after that. Remember that unordered list, the elements do not have an order, but the positions have an order. And that's what we're looking at, the positions. So what I wanted you to do for homework was to see if you could come up with an attempt to define the item type class. Now, I told you to do it for double, but I have a sneaky suspicion that when I do this example, you'll have very little trouble making the changes. I did it for double, and I'll show you what I did. So here, and I'm also going to put this out in a few minutes as another file for you to look at. what I did was I used the usual, and then I defined my enumerated type REL. Now I tried using less, equal, and greater, and the machine told me that there was an ambiguity. So I think they might be reserved words. I switched to these smaller words. I called my class item type double. I have a generic constructor that doesn't get any values. I have a constructor that gets a value, and I have one field. The field is a double. Now, I'm going to compare two. This is something that people have trouble with when we had trouble with this in CSC 104. There are two item values, item type doubles being compared. Remember that this is a method. We attach it to some method or some object. So when I use it down here, Q1 is the object I attach it to. So Q1 inside compare to is anything I use that are values, they belong to Q1. Val is the val of Q1. If there were other parts, it would be the part of Q1. If I want the parts of Q2, in this case X, then I have to specify them. I have to say X dot value, because just plain val belongs to the first one, not the second one. Now it's a very simple setup. I just put down the items there and do a simple if. I had an init so I could start them off, and I had a read so that I could read in values, and the private is that one item. What I did was I described 4 item type doubles. Now originally I had used them a little bit differently. I really only need Q1 and Q4 for what I'm doing here. And if you look, to compare, to get LE, I had to put REL : so that it knew what LE was. And I just have the normal here. Now, let's see. I still have this program up, so let me see if I can run it. This is this is the second version of the program. In this particular version, I did it for a string. And if you look, there's almost no difference. This part's the same. It's just I can't use less than for strings. So I had to use .compare. And everything else is the same. It's almost, and the string, of course, the val is now a string. So I will compile it. Oh dear, now what? Let me try again. All right. Sometimes you have to use build. You can't go with the shortcut. All right. I'm going to try clicking here and rebuild. All right, that worked. Now, before we go on, I made item type double Q1 no, N-O, capital N-O. So when I test it, the first value I'm going to put in is apple. Now apple is before no in the alphabet. I should get first is greater than second. Now I'm going to try no. I should get that they're equal. And now I'm going to try wow. and I should get that first is less than second, and I do. Now that's how you do it. It's relatively simple. You can see that I just used an if there for what came back. And I actually got away without the REL, so it's possible you don't need it. You can try it without it because it worked for EQU. I didn't notice that till just now. So what I'm going to do is post this video, and you will also get a file that I'll call like 3.5 for the notes that will have this program and the one for double. Good luck. Work on the homework. See you later now.